Coffee is a multi-billion-dollar industry. Just in October 2022, 9.8 million bags of coffee have been exported worldwide. 2 billion cups of coffee are consumed daily. Hello everyone, I am Sahitha Karapitiya from the Department of Agriculture Engineering, Faculty of Agriculture, University of Peradeniya, presenting you my research project, Simulation of a Temperature Profile of Coffee Beans Roasted Under Far Infrared Radiation. In this video, I am going to cover 4 topics. Number 1, the background of my research. Number 2, the methodology that I have used. Number 3, the results that I have to share with you. Number 4, finally my conclusions. So let's get on to the video. Roasting is the most important step in coffee processing. In conventional roasting process, they use convective heating where they blow hot air onto coffee beds to roast coffee. That's good. But the problem is it consumes more time as well as energy. Research have shown use of far infrared radiation in agriculture processing saves more time as well as energy because it can rapidly heat materials. But there is lack of research conducted on the topic of using far infrared radiation in coffee roasting. So the aim of my research is to see and investigate whether far infrared radiation can be effectively used in coffee roasting, and to simulate the center temperature of the coffee bean and predict the surface temperature when it is roasted under far infrared radiation, and to see whether all roasting degrees can be obtained when we roast coffee using far infrared radiation. The methodology consists of mainly 3 sections. Number 1, to build a computer model. Number 2, obtain experimental data to validate the model. Number 3, roast more coffee beans to see whether all roasting degrees can be obtained. Well, the results of my study was really satisfactory. I'll break the results into 3 sections for you to understand. Number 1, the validation of the model. Number 2, prediction of the surface temperature. Number 3, determination of the roasting degrees. There was a good agreement of it between the model predicted data as well as the experimental data that I have obtained. When the coffee beans are roasted using convective heating, it takes about 20 minutes to heat the coffee beans to a temperature about 240 degrees Celsius. But in my study, I found that it takes only 45 seconds to heat the center of the coffee bean to a temperature about 300 degrees Celsius. So that's really a savior of time. So in the second step, I predicted the surface temperature. You can see that the bean surface is unevenly heated, which is needed in coffee roasting. It was observed that the light roast, medium roast, dark roast, all the 3 essential roasting degrees can be obtained when we roast coffee beans under FIR. So let's move on to the conclusions that I want to leave with you. First and the foremost, I want to conclude that far infrared radiation can be effectively used in coffee roasting, and all the coffee roasting degrees can be obtained when we roast coffee beans using FIR. And finally, this model can be used by aspiring researchers as an aid in their further research. Let's hope for a sustainable agriculture with a better coffee production. Thank you for watching.